Welcome to the Silicon Learners. Today's topic is sequence detector with counter. In this video, we will study about overlapping versus non-overlapping in the Verilog, and also study about what is the type we can describe our FSM. We will study about FSM, representation of FSM with counter and with shift register, and impacts on the hardware. So let us start it. So first of all, what is overlapping and what is non-overlapping? So let us see. In the non-overlapping, after the detection, in this example we take 5 consecutive one sequence detector. Okay, so in the non-overlapping, after detection it reset completely. For the next sequence it start fresh from the beginning. And in the overlapping case scenario, after detection keep the last bits. It stores the last bit in the memory. Okay, so what happened exactly I show you. In the non-over If we take non-overlapping case, for 5 consecutive one input, one, and 1, the corresponding output will be first 0, second 0, third 0, fourth 0, and at the fifth input of 1, our output will be goes 1. Now, if we give sixth input as a 1, in the non-overlapping case, our next sixth output will be 0. Means it not the store previous bit in the memory. Okay, we see what happened at overlapping case in this condition. Okay, so if we give input of 1, 1, 1, 1, 1 again, the for the inputs 5 consecutive ones input, the corresponding output will be 0, 0, 0, 1. Okay, now at the sixth input is our 1, the output will be 1. Means it is store previous 4 ones in the memory. Okay, so what affect it on the hardware, what impact on hardware architecture? So due to overlapping, it demands complex control logic to track data dependencies on and manage multiple pointers simultaneously, where non-overlapping uses simple counters in clear segment state machine. So in point of view power consumption, overlapping demands high dynamic power. Okay, but non-overlapping has lower power. So this is the effect on hardware of overlapping and non-overlapping. Now I will show you the simulation of overlapping and non-overlapping on the our hardware. So this is a program uh, here. Okay, this is a overlapping program for the 5 consecutive ones. It will detect sequence 1, 1, 1, 1, 1. Okay, we allow overlapping. Okay, so here we describe our all 5 states, and at the fifth states, when the input hits 1, our next state will be S5. Means if the at the fifth state, if input is 1, it will stay at a fifth state, not at a clear. Means not reset at the present state as 0. Okay, so here is the simulation. First of all, we will all add these objects in the wave and run this again one time. So here this you can see the output. Okay, for the 5 consecutive ones, you can see at the first clock edge, this is second, this is third, this is fourth, and this is fifth. At the fifth clock edge, our output goes to high. But when we Reset means when we give input 0 at the next locate, our output again goes from high to low means 0. Now you can here observe for the consecutive 5 once again our output goes 1. But you can see another in the next locate when our input is 1, output stays remain at the 1. It is not changed and this is called overlapping condition. Now we are see non-overlapping condition. So here is non-overlapping condition code. You can see we define at the state S5 if input is 1. Our next state is S1 means FSM resets after the output gets 1. So we are observe the simulation for this. Here it is. First of all we will add all objects on the view and just run it. You can observe the result. After the 5 consecutive ones, our output hits 1. But at the next of the edge of clock, our output goes again 0. Even when input is 1 at that next stage of clock. And you can see here also. At the 5 consecutive ones again, output hit 1. But at the next age of clock, even when input is 1, our output goes to low. So this is a non-overlapping condition. Now next we will understand how we can describe our FSM. What is the methods of describe our FSM? So if we use pure FSM method for the large sequences like 32 consecutive ones or 1024 consecutive ones, it will not reliable. This pure FSM method not reliable for this 1024 ones and 32 ones. So what we did for this type of problem, we did FSM plus counter method. In the FSM plus counter method, our hardware will be less use. So that's why we use FSM plus counter method. Okay. But in the FSM plus counter method, there is one problem at the overlapping condition. In the overlapping condition, the code will be complex for the counter logic and FSM logic. Why? Because it demands counter control logic and more complexity. So that's why for the overlapping condition, when 32 ones required, and large sequence required, we are use shift register method. Okay, so first of all we study what FSM plus counter will be does. So in FSM plus counter method, FSM have two states. First is ideal state and second is our detect output detection states. Okay, and another is counter for the run logic. Okay, now I will show you why it will take less hardware than the pure FSM method. Okay. So we move our quarter tool. Here is our 32 ones detection. Okay. Program. This is the pure FSM method. You can see our code how much complex. We describe all 31 or 32 states for this. Okay. So let us see hardware. From the compilation report, you can see there is 33 logic elements utilized by pure FSM logic. So this is a pure FSM logic. Now we are shows our FSM plus counter method, how much utilize hardware by it. So let us compile it. And you can see here, it utilized 17 logic elements, means 17 flip-flop utilized by our FSM plus counter method. Why? So we can see this code and determine. So these are two states utilized by our FSM, and this is a 6-bit counter. Okay, it will count up to 32. So this that is way to define 32 consecutive ones sequence detector. By pure FSM method, it needs more hardware and much complex hardware. Where we use when FSM plus counter, it requires less hardware. You see. Now these both are non-overlapping scenario, but in the overlapping scenario, as I described, net safe register, because in the overlapping case, FSM plus counter is not reliable. So let us see it. Here is our shift register code. We describe 32-bit shift register. Okay, and here you can see it is utilized 33 logic elements, more than our FSM plus counter method. But still we use this type because for overlapping case scenario, shift register method is still reliable than the FSM plus counter block, because when we use FSM plus counter for the overlapping condition, in the it will demands combinational logic. So at the end, it will utilize more logic elements than this shift register method. Okay. Now question arise when to use which. You will use simple FSM for 6 states when the states are small, okay, for short sequences. And you will use non-overlapping for the short sequences, overlapping for protocol detection, data farming, and pattern matching. If we consider FSM plus counter, it will use for the big logics like 32 consecutive bits, 1024 consecutive ones, this type. And in the FSM plus counter, we will use non-overlapping for the long sequence and area constraint design. While we will use overlapping for the avoid gets messy and use shift register method. In the overlapping method, we will use shift register instead of FSM plus counter method. So how uh, it is effect on VLSI industry. Okay, so overlapping FSM or shift register. It is used in protocol detection. Non-overlapping FSM plus counter used in error detection, and non-overlapping FSM means pure FSM used in power management. So that's why it is matters in the VLSI industry. In the VLSI industry, all matters area, speed, and power. So that's why we use different types of FSM for the describe our logics and describe as per our need. So thank you so much for the watching this video. We will meet in the next video.